but this is an outwash plain. So it's very shallow gradient. This is what you're looking at is probably 2 feet elevation, and 3 miles up river at Coonamessett Pond, it's 33 feet. So it only goes up 30 feet, and it's there. I mean, there's no precipitous drops in that. It's pretty consistent. 95% of the water you see here comes from groundwater. I'm getting binoculars so we can look at the ospreys.
And that's where you would get more of the nighttime running, so they don't get, because when they're in it and during the daytime and it's very clear or there's not a lot of cover, they can just get picked.
Exactly. And you might see them. And what happens is when they catch them, however they catch a hold of them, they turn them so the head of the fish is forward, and so it's aerodynamically best for them to get back. So we're going past some fencing that actually Massachusetts Environmental Trust grant we had to do these interpretive signs. Part of the money of the grant was to do the research for the signs and to actually design the signs. But we did that all. It turns out that there was somebody here who called me up and said, I'm going to have a knee operation. Would you like help with those signs? And I'm like, yeah, I would. And then it turns out, while we began the project, then she went away for a month to the Azores and had a bike accident. The bad news is I have a broken hip. The good news is you have me for another 6 months. So we did all these signs. But I wrote Massachusetts Environmental Trust, and I asked, since we had so much contribution from volunteers, could I spend the money on safety fencing? There are 3 key organizations that play a role in this project. One is the town. It's a town project, and they've done all kinds of little jobs, and some not so little. And then the other 2 groups are the 300 Committee, which is our land trust. Over the years, they have added to the Greenway, which now is more than 250 acres that border the river all the way from Coonamessett Pond, which is 3 miles from here, actually all the way to where it goes into Great Pond. And then the other organization is the Coonamessett River Trust. Many of the members are scientists, and they've done all the monitoring that was required for this project. When we were first thinking about this project, when we were just starting, the southern part of this dam was made of these granite blocks. And I said to myself, wow, those blocks have been on site since what was first here after the Native Americans used the resources. When the first settlers came, this was the first river that was dammed, and it was dammed in 1700, and it was Philip Dexter who dammed it. And so these blocks have been on site for more than 300 years. So I said, this is a fabulous history of this valley. What an opportunity to walk along this greenway and have interpretive signage. So that's what we did. So we have, when we finish, 6 more to put up. So somebody from the 300 Committee and I walked all the trails with the GPS. We worked closely with the town, so we had a meeting, and the policeman said, what are you going to do? Are you going to have markers every mile, like our bike path has? So I thought, well, each area we can designate between where roads cross as a different color. So we have these different trail areas. And hopefully if somebody got hurt, you could say, well, go back to the last map, and these maps are pretty frequent, what color's around it? So at least you know what area it's in. And as far as monitoring the river, Coonamessett River Trust has had a counting program since 2004, a nighttime counting, right? It's 7 to 10 every day from probably the first week of April when the run starts till the end of May. For the last 5 years, they also have a tagging program. So they tag 500 of the fish to answer questions like, how long does it take to get up to Coonamessett Pond? Well, the fast ones can make it in 5 hours. And even when there was a cranberry bog here, they had to allow the fish to run through these fishways. In addition to the tagging program and the accounting program, they also monitor changes in the vegetation. So there are 40 plots here that have been monitored since prior to restoration and every year after restoration. But the amazing thing is, so imagine for 200 years, from 1700 to the late 1800s, you'd be looking out at a lake here, because this was a mill, first for grist, and then it was a woolen mill. And then the late 1800s, the mills went elsewhere. This was all drained and converted to a cranberry bog. So for the next 100 years, to grow cranberries, you put sand on the surface, because cranberries are wetland plants, but they don't like to have their feet wet all the time. They like to be above that. They irrigate them. Basically, you're separating the wetland soil, the peat, from the surface. So they stripped a foot to foot and a half to 2 feet of sand off this whole surface, put it where it came from, which are called borrow pits, B-O-R-R-O-W. Then it was a mud hole. In May 2018, and then for the upper part in May 2020, it was all mud, and it was made into a pit and mound topography. So you had different, sun plants, shade plants. You have plants that like more wet, plants that like more dry. Within 2 weeks, it had greened up. Within a month, you had a meadow like this. Except for the trees and bushes that you see, everything else came up from seed that had been buried for 300 years.
Wow.
Isn't that incredible?
That's incredible.
And it speaks to the resiliency of these systems.
Right.
Yeah, this is the third major cranberry bog restoration. The first was in Eel River in Plymouth, and then the second was Tidmarsh in Plymouth, and then this is the first one on the Cape. And now so other groups I speak to are other towns on the Cape who are planning to do cranberry bog restorations or some kind of restoration. I just want to mention this to you. So the other thing, that the 300 committee will lead nature walks here, and then the Coonamessett River Trust has worked with groups in town, and for the last couple of years, but obviously not for last year because of COVID, all the 4th graders come here for a field trip. These are all pictures that 2nd graders, every one of these fish was a painting by an individual 2nd grader. And then they were all painted on a background that the high school students did. And then this was like 2 feet high and 8 feet wide. We've waterproofed it, and one of the lumber companies in town, I was talking to him, getting some historical pictures, and I was telling him about this project, and he offered to make borders for all these out of wood. And I said, well, we don't really need that because we're going to use this other company. But I said, there is something that I need framed. So I told him, and he went to T-Ticket School 40 years ago, so he'd love to do it. And so now it's on the side of T-Ticket School.
Oh, that's awesome.
Yeah. So the other thing they did is each of these kids, what the Coonamessett River Trust did was to raise money for the equipment they needed for this tagging. You could sponsor a fish, for each fish for $10, and then follow that fish. I went and talked to them, then they did this, then they had their fish to follow, and then I followed up at the end. What I really hope to do is get as many people in the town engaged in doing something here and contributing to the project so they can feel it's theirs. I mean, this is a town project. So then I said, it's a system that's set up that every time the fish goes through, it detects that particular fish. So the other thing that was really important about that was they started that program, I think the year we took this dam down, but the next 3 blockages were still up. One of the fish left here one evening, got up to the next dam, middle berm, which we'll go to, turned around and came back. Went up again, turned around and came back, and it wasn't until the next morning that it went up and went all the way through and made it to the pond. Not only did that take extra energy that could have been used for reproduction, but also exposed that fish to predation that much more time. Being able to show that, applying for grants. I mean, you look back and I say, well, we had 17 grants and $4 million for the restoration and $1 million for the Heritage Trail. It's like, oh, well, that all happened. It's like you guys have written scientific papers. Yeah, you never write the introduction until you've finished your paper, right? Because it's not like you kind of knew what was going to happen. You did your project, you have your figures, you do the results, the methods and results, and then you do your discussion, and then you say, well, what kind of story do I want to tell people about this?
Right. Yeah.
So, but, you know, there were times where sleepless nights that I had saying, how am I going to get enough money for us to start this phase of the project? Because you can't, for a town project, we can't put out an RFP if we don't have the money to pay for it. So, and in fact, that was the big role that the Municipal Vulnerability Preparedness Program played. Their grants are just for a year, which is any kind of project like this, even if everything worked perfectly, is going to take a couple of years, because you have to do conceptual planning, then you have to do the actual engineering, then you have to do the permitting, then you have to make sure you have enough money, and you hire the construction. So at the minimum, it's going to take 3 years for a project like this. This project took over 10 years. But we got to phase 2, and we were missing some money, and I'm like, what are we going to do? And then the MVP program came up. The grant we submitted was kind of the final piece, but everything was shovel ready. We had all of our permits, we had all the rest of the money, and so that enabled us to do this project. We wouldn't have been successful without them. Yeah, so this is exactly where the dam was. So the quick and dirty restoration story, and you guys are restoration ecologists, so you already know this, is what are the stressors to the system? And how can you mitigate those stressors? In this case, the blockages across the stream were stressors, and so they've all been moved. I mean, not only did it block the stream, but as you already know, the stream channel is the obvious part of the river, but this whole floodplain is the stream. So it opened up the whole floodplain. But this is an outwash plain. It's very shallow gradient. This is what you're looking at is probably 2 feet elevation, and 3 miles up river at Coonamessett Pond, it's 33 feet. There's no precipitous drops in that. 95% of the water you see here comes from groundwater. Only 5% comes from surface water. But of that 95%, about a third come from ponds, but those ponds are fed by underground spring. The rest, 60% of the water that come here comes in along as the river heads out to sea. And of that 60%, 45%, so 3/4 comes in this last mile. One of the problems with these rivers is, not only was it wide and shallow and a sandy bottom, but it heated up a lot. Over time, the shade that was planted along the side is going to help with that. But in addition, the really strong springs that are along the river valley were tied into the whole system. And so as we walk along here, I'll show you one of them. We've been talking about herring. Obviously, we're interested in having the herring come back, but the other important fish are the American eel, which is also a species of concern. And the American eel, they've really declined. They were very important to the Native Americans and very important to the Portuguese islanders, they came to the area in the late 1800s to work at the mills and also to pick cranberries. A lot of people I know who were in their 40s, 50s, 60s would go eeling when they were kids, but there are not hardly any eel left. They got this far, you know, to where there was just a fishway through here. And obviously some got further north, but not that many. But one of the things that made me really happy the first year after this phase 1 was done is that Steve Hurley, who's our freshwater fish biologist, said that this entire new area was chock full of elvers, little eels. So hopefully the eel population will rise. The other fish that Steve's particularly interested in, this used to be a big brook trout stream. In fact, this was so important that people would come from Boston and New York for fishing holidays, for sport fishing, because brook trout that are in these kinds of systems will go out to sea and turn into salter trout. So instead of being this big, they'll get this big, you know, and weigh 3 times as much. One of the other goals of this restoration is to restore a salter trout population. And brook trout disappeared completely from this system probably 50 years ago, probably because of habitat loss, including converting this to cranberry bogs. But Steve reintroduced brook trout, now it's probably 8 years ago, just north of where we did this restoration, where the stream is always a cold water stream. And it was like wildly successful. For 2 years, I think he brought 30 fish in. And now there's a self-sustaining population in the river. And they come here, and not only do they come here, they can go up these cold water ties to the river. Even if the river's warm, they have refuges in these cold water areas. And this pond, in fact, is one of the cold water areas. So this doesn't this look like this would be a big heat sink?
Yeah. Mm-hmm.
Yeah, but it turns out there's a really strong groundwater input to this. Oh. The river itself has been made very lower part, phase 1, 50% longer, but along the whole 1 mile has been made 33% longer by adding bends. And so every clump of these vertical logs is a bend. And what happens is you look along here and you see root wads, right? Mm-hmm. And so those root wads are the top of 3 sets of root wads. So connected to the root wad is 24 feet of tree. So underneath here, you have 3 sets on the outer part of the bend. You have 3 sets of logs. And the holes between those logs, these vertical pieces have been driven. So basically it's to stabilize this outer bend. Because if there is a hurricane, this is where the water's going to rush up. Mm-hmm. So the ocean is like 1/3 of a mile downstream. The salt water, on a high tide, salt water comes up to within probably 100 yards of here. But you see we have a stream gauge. Mm-hmm. And Chris from Coonamessett River Trust and Nick Nelson from Interfluve, who designed all this, were looking at the records. And a couple of years ago, they noticed in March, there are these 3 big peaks where the river went up. And it's like, well, what happened then? Well, it coincided with 3 nor'easters. Mm-hmm. And it's not that the salt water got pushed this far up, but because the water got pushed up. So you look at a map of Falmouth, this goes into a long linear estuary called Great Pond, but the water was forced upward and basically dammed up the river. And so the river rose and then it went down.
So the salt water dammed up the river?
Yeah.
Because of like the different densities, so it's not...
Well, no, it was pushed up by the storms.
Okay.
By the storms, yeah.
That's so cool.
Yeah. And so now Chris has installed another because this will increasingly more be influenced by that. But so this is an area, talk about design. So the kinds of things you think about when you're designing a project like this. These were town conservation lands, but they were leased to a grower. And so the same family had the lease until the early 2000s. But Nick Nelson, when he first showed us what the design was for this, he was going to fill that in, because you have to do something with the sand you're taking off the surface. So that was like an obvious area. And everybody who worked here, especially the Coonamessett River Trust people who were here every weekend, said, you can't do that. That's Turtle Pond. All the kids like to see the turtles there. And so we left it. And then it was after that we started doing more studies, and we realized that not only is it good for Turtle Pond, but it's a good cold water source. Normally, you see a lot of painted turtles pulled out, but I don't see them now. And when I was here, I can see them on the other side of the Turtle Pond. When it's hot, all they do is just hang at the surface. They don't pull themselves out. So this is where snapping turtles lay and other sandy spots. Mm-hmm. So it was exciting to come along and kind of go, ah!
Yeah, you see the markings.
Yeah. And then this, again, working with the town, having a town meeting. So the policeman wanted to know how to find people. The fire department wanted to know how to bring equipment down here in case they had to go in. So now it's almost a mile away where they would go in. And so we put in a turnaround for them. So that's what this is. Oh, early on in planning the trail, we've had 2 meetings that including police, fire, DPW, the 300 committee, and conservation to discuss those kinds of issues. Try to foresee what problems might arise. So I was here with Mark, who's our land manager, with a Boy Scout. We'll see whether this comes to fruition, but he's working towards his Eagle Scout badge. And his dad is in a wheelchair, and this is wheelchair accessible. And the company that's doing that will be putting this on that side of the river. So basically, this is a 1 mile fully accessible trail. Mm-hmm. And he wanted to know if his group could build, a rustic-looking bench here, so that when his dad comes around, they can, he and his family can sit and look out here. This was part of a perimeter ditch. So when this was a cranberry bog, the entire outside had a perimeter ditch, and then it had ditches that went from towards the river out to here, so that when you irrigated, all the water would quickly go downstream. But some of these were incorporated into the design, because there's this area here also had really strong cold water inputs. And then you can see lots of woody debris was left for habitat. And when you look out there, if you don't do anything to a cranberry bog, for many cranberry bogs, it'll turn into a pine forest. So, because pines also don't like to have their feet wet. Mm-hmm. So where you see pines there are mounds as opposed to pits. There's so many people who walk it now who just love it. So see the butterflies? Butterflies, bees, damselflies, dragonflies, those populations just exploded. The 300 committee and the town community preservation is funding, that's a major gateway to the greenway. And there's parking up on top. And an important element is when we have school groups come, that's designed so that a bus can pull through and drop the kids off, and then the bus can park further down. Back way in the beginning when I first saw those granite blocks was well, we can do something with this and have some kind of an area for people to gather. So that went through that went through various evolutions, right? But what we decided on was we used the blocks to make a series of seating, just rustic seating. And then you see the two head walls. The base of those head walls will be the floor of a walkway. And where you see those iron pieces, those pipes will go up to support a circular walkway that will come out. View up and down the whole river.
Oh, that's awesome. Cool.
Yeah. So I actually said to them at one point about using these historic blocks, which it's not as easy to do that as fancily cut blocks, right? But this was the whole inspiration to do this. Those blocks are the history, the bridge between early 1700s and the present. And this walkway, this elevated walkway, is going to be the bridge between the present and the future as this, a succession occurs here.
Yeah. Both natural succession and human succession
Right.
in a way.
Right. As this all grows up, which it will, I mean, I don't think it'll be as dense as downriver there, but there are going to be trees along here. As this grows up, that walkway will still enable you to look up and down the river. And I said, you're not going to be able to see the river as easily as you can now, but eventually, fishermen and stuff will find their way in. So there'll be pathways from here into the river. This is one of the tributaries. When we first did this tributary, I named it Hurley's Creek because Steve Hurley's our freshwater biologist. And he said to me a year or two later, I don't want it named that in case it doesn't work. And I said, I'm sorry, Steve, it's too late.
Hurley's Creek.
That's what I refer to it as, and that's what everybody else refers to it as. Where I'm standing.
Really?
This is where Middle Berm was. And these pictures were taken as part of a study of child labor. And Lewis Hine went all over the United States, oyster shuckers in Louisiana, newspaper boys in New York, kids in the mills in New Bedford. He's documenting that children were used in picking cranberries. So what happened was, this brought the people from New Bedford who had been brought to work in the mills in Fall River, came up here to harvest the cranberries or to work in the cranberry fields at the right season. And many of them were very thrifty. They didn't get much money, but they were very thrifty. They saved their money. They bought land to the south of Route 28 here along these peninsulas that are divided by these estuaries and grew strawberries. So in the 20s and 30s, half the strawberries in Massachusetts were grown here in Falmouth. So we have two migration stories here. One of them is the American eel. And American eels spend their adult life in freshwater and go out to sea once in their lifetime. When they get to 15 or 20 years old, and they go down to the Sargasso Sea, and they reproduce there, and then the larvae somehow make it to the Gulf Stream, and this is what they look like. This is how big they are. They're called glass eels.
That's the larvae, or?
The larvae is microscopic, but then they turn into these glass eels, and as soon as they get into the rivers, they start getting pigments in their elvers.
Oh, really?
Isn't that incredible?
That's amazing. But why here? Why right there?
Well, listen, even more than that, all the eels on the Atlantic coast and the Gulf Coast go here. There's a different species of eel, not the American eel, that's from Europe. They all go here also, but it's a different species. And then they make their way back to these areas. Isn't that incredible? This is an incredible natural history story.
What a massive migration.
Yep. Further upstream, we have another restoration project. So there are other issues with the river. This is a fish ladder, and some of the fish come up here. But we also have a bypass stream over here that's cold water. Probably more of the fish go up that way. And this is called Pond 14. And I can't tell you how many people have said, well, is there a Pond 12, Pond 13? And I said, no. I said, my understanding is when the USGS mapped this area, probably in the late 1800s, in the middle of this pond, they had the figure 14 for elevation. And so from then on, it's been called Pond 14. We'd love to have a white cedar grove established here to add to the mosaic of wetland habitats. There's places for birds and stuff, but it doesn't serve as really good wetland habitat. The restoration contracts themselves required the company to monitor and take care of invasives where they worked for 3 years after completion. I hired them, but as much as possible, we do have to put together a management plan because it's the town and the 300 committee. So underneath those root wads, the water can get 4 feet deep. I mean, it'll always be deeper than to the side, but sometimes some of them are as deep as 4 feet deep, little pools.
I love the 300-year-old granite.
Yeah.
So cool.
Yeah, it's really been fun. Hello.
Hi.
How are you? Glad to see you're doing what you're doing. And I understand you've had it even hotter where you guys are from.
Yeah, it's been warm.
Brutal.
Warm.
So I have to come out and visit your river. So I actually have a book of all of our interpretive signs. And we have a set to put up above there that even bigger than this, but one will be of our partners, and they're actually even more partners than that. And then one is of a map of the whole area. And then another one is the geology of the area, because that's really important in terms of hydrology. And then two will be next to one another, and it's a timeline, and the top part will show human use of the land, and then the bottom part will show the impact that it had on the environment. And then the last panel is a restoration panel.